Today here, a TRX bench special. After a long time we have again one of my most loved projects, and that are old tube radios. So we have here an old Telefunken from the 50s, and we got it in with receive problems, so it is only producing some funny noise and hum and whatnot. So that is really a nice project. So let's see if we are able to bring this old boy back to life. Shall we? And here we have a front view of this really nice old radio. Telefunken was a very well-known brand in Europe, and it is a product of Germany. And this radio must be around 1953 or so. And you know, that was a time where ultra shortwave was already used very often, and that was FM radio. So that was already a very nice sound quality, even for an old radio like this. Okay, so let's connect the radio to power, and let's see the behavior, and let's see if we can confirm the fault report, what we get so far. And well, then let's see what we really can do. And have a look, the radio came in with the original paper bag, and there is the description, and very nice, we have the old original warranty card. So obviously the radio was sold on the 21st of April 1954. Very nice, and that is here really the original card, so the warranty card with all the numbers and stickers and stamps and what have we. So wow, that is really nice. Okay, so let's go into our restoration. Well, and as you might know, we can't just take a radio like this back into service after such a long time. So we do not really know what is really the problem with the radio, and if you simply connect it to your wall plug and switch it on, you might completely blow it. So therefore we have here our protection lamps, which are in series with line, and of course we have our insulation transformer connected as well. So, and we really gently bring it up to the voltage which are needed to get it into operation. And well, if you don't understand what's going on here with our light bulbs, which are here on this little board here, then simply watch my video 43. There you get all the information, what it is all about, this light bulbs here. Alright, so now next let's gently increase our output voltage, and let's see if we can get it at work. Alright, so I hope you can see all important things. So here we see the voltage. So this radio will be operated with 220 volt. Yeah, and it is really 220 because back then the networks were 220, today it is 230. Anyways, we leave it on 220 if we get that far. So let's start, and I am increasing here my transformer, and I do not know if you see that this bulb here is gleaming a little bit. So that means I switch this off and switch the next step in, and then we have already 5 watt, and let me increase it here a little bit more, and you see maybe that it is start gleaming. We are at 107 volt, so gleaming is going back a little bit, so that is just fine. Let me increase it a bit more. It's gleaming, and I switch this additional into our line. Once again, watch video 43 to understand fully what's going on here. And let's increase it more. So 16 watt, so that all looks quite nice. 156 volt. And I see that now this lamp starts gleaming as well, or again. So that means, but it is still just fine. I'm really carefully to do nothing harmful here to the radio. So now I switch in here my biggest lamp. We are at 170 volt at 21 watt. So let's increase it. And I hear there is hum already in the background. Okay, so now this is starting to gleam. So I put this both back in as well. And 36 watt looks fine. 220. Very good, 40 watt, so that looks just fine. And now let's go back here to the radio and let's see what's going on here. Alright, so we see we have light here. In the background there is a station, but yeah, you hear all the crackling and the noise and the hum. Yeah, definitely no receive possible. So a lot of hum and crackling and what have we, but no receive. So that means I believe we really have here a nice restoration project, and that means especially for radios like this we have to swap out most likely all of the tar and wax capacities which are getting leaky over the years, and that is most likely causing here the issues. And therefore, yeah, let's take the radio apart and let's see if my assumption is right, and then let's see how we can go ahead. Yeah, and the back of the radio, and there you see 220, so that is the voltage, and that is what we put in. Yeah, we have to loosen here 3 screws, and then we are in. Alright, ready for first inspection. So what we can see first, the line cord has been changed obviously a while ago, and yeah, that has not been done very professional, but so that is no problem. And what you see, we have here no protection contact, so that means that there is still a risk of electrical hazard. So that is something we need to look after a bit later. And then you see, yeah, we have the dust from, I don't know, the last 50 years. I don't know. So you see here, there are really a lot of dust here on our tubes. And yeah, we see as well that here our medium wave antenna is falling or fell out here, out of its holder here. So that is something we need to address, but of course later. So I guess we have to glue it in. Let's see how it was. And well, what we definitely need is a completely overview, and therefore, I mean, we have here yeah, a lid that we can could take off, and then we would have access here to you know, the chassis. But the best in cases like this, we really take out here our entire chassis, and then we have really access to all what we need. And yeah, that is the best what we can do in cases like this here. So we should be simply able to loosen these screws here, and then we should be able to pull out our chassis and see if that is all we need to do. Okay, we have to disconnect the speaker, of course, from the audio transformer, but that is all. Yeah, exactly, that is all we have to do. Very nice, no problem. I just disconnect here our wire, and then yeah, it is no big deal to get the chassis out. And here it is. So now we only have here to disconnect our speaker wire, and then we have it off, and we can do another inspection, or a more in-depth inspection. Okay, and I've started here to take off here the knobs, simply because I want to take off here our dial glass, just to make sure that we do not jeopardize it while we go along here our restoration, because you know, this glass is very sensitive, and if it breaks, it is really lost. So therefore I yeah, simply take it off. So we have to take or we have to loosen here the screws at the side, and then we can take off here finally our knobs, and that gives me the opportunity to take off here our dial glass, which makes me feel a little bit better. And here we have it, and I put it now to a safe place, and we will clean it more or less as one of the last steps, and then we install it back. But now it can't break, and yeah, that is what we really want. Okay, and right here from the start we see what I really expected. So down here we have old tar capacitors, right? So that is an old, what is it, a 25 nanofarad tar capacitor, which is most likely leaky, such as we have it here at our audio transformer, right? So tar, and here is another tar capacitor, and so these are highly suspect, and they definitely have to go. Additional to that, we have here our rectifier, and that is old style, how is it called, selenium or selene, or I don't know, but maybe that this needs to get swapped as well to a modern diode, silicium diode. And yeah, let's have a look underneath. Okay, it must be called selenium, and yeah, that is something we need to check, because that could be leakage as well, and even if not, I think we have to double check it, but I think it might be good to take care here on our rectifier. Okay, and that is the expected view. So we do have here tar capacitors, and as well, can you see it? Maybe down there. So that are coupling capacitors and whatnot. So a 10 nanofarad obviously, and yeah, so for sure we have to swap them out, and yeah, this capacitors here on the tone circuit here most likely as well, and here we have our ratio electrolytic capacitor, I believe. I have to double check it, but but by the look of it, it must be the ratio capacitor for the FM demodulation circuit, and yeah, that is electrolytic one, which definitely needs to be swapped out as well. And down there, that down there looks like the audio final stage bypass capacitor. So you see really a lot of stuff to do. So and here another, where is it? Over there, another tar capacitor. So you see really a lot of stuff we have to check, because if we have here leakage capacitors, what I really expect from experience, that is 90% of all the problems old tube radios are having. And yeah, so let's start. And of course, very important here is our main filter cap. So that is most likely a dual pack. It is an electrolytic, and yeah, when we turn it here around a little bit, so we can see in a second that we have here two wires coming out of our main filter cap, and chassis is obviously here ground or not, because that is in question, because it looks like, so let me see what we have here. No, it is connected. 8, obviously. So that is what we need to check, because I've seen that this radio has not a main separation. So that means depending on how you plug your wall plug, you may have your live on the chassis, your live wire, which was common back these days. So that is what we need to check. But other than that, we have to check, of course, here our main filter cap, because it would be a shame if we need to completely take it off, because simply it looks nice to have this old capacitor here still in for design reasons. And of course we have here our antenna hooked on, so we will need it, maybe or not maybe, we definitely leave it in, even if we have to substitute it by a modern capacitor, which we can easily get here under. Okay, I have connected here my capacitor analyzer to the main filter cap, and let's simply check out the results to discuss it. Okay, so let's test the value. Should be 50 microfarad, and it is 67, so that is not so far away, but well, might be already showing an issue. And then let's go here to capacitor leakage, and once again 50 microfarad with 350 volt should be 164 microamp. So let's simply start here. So that is overload, so that is 9.2 milli, 8.8 milliamps, 8.6 milliamps, 8.5 milliamps. So we are looking for let me say 200 microamps, and even we take into account that it is a very old capacitor, it should not show more than, I don't know, 500, maybe 600 microamps, but you see it more or less sticks here at around 8.2 milliamps, or it is decreasing very, very slowly, and that is not how it should look like. So definitely it should go down much faster if it would 100% okay, and that is what we expected. So all capacitors are definitely in trouble here. Simply let's compare it here with a modern type, 47 microfarad, 500 volt. So let's see how that capacitor would react. Okay, so basically the same condition, it is connected, and now I press here first capacitor value, and you see that is very, very close. So it is indicated as 47. 46 is really nice, and now leakage. So let's see what we have here, and yes, it also starts high, but you see how fast it is dropping, and now we are at 390 microamps, right? And well, it should go down to, I don't know, 100 something, and you see it is dropping really, really nicely. And of course it always takes a while when you take you know, a capacitor out of the cabinet, but now you see we are already under 200, and that is really how it should looks like. And yeah, 160, so that is a value what we would expect. You see it is still going down, and that is exactly how a healthy capacitor would look like, right? And I've once again here connected our filter capacitor and the tube radio, and once again our value is a little bit too high, but that is not a drama. But once again here our leakage test, and you see, yes, it is dropping, but you see it is much too slowly. Maybe the capacitor needs to get reformed, which is possible. But you know, on the other hand, the capacitor is 50 plus years or 60 plus years old, and yeah, that is, and I show it to you that you really get an impression what's going on with old components. So that is really important if you start with electronics, that you get a feeling for what's really going on. And you see still 7.6 milliamps, and that is definitely too much, and that is one reason why, you know, you hear the radio humming and such. So this is definitely a problem. Okay, so just a little impression what we are doing here. So finally, to get access to, you know, all of our tar capacitors, and yeah, what have we down here? So you see there is another one underneath. So we really needed to take off here some of our resistors, right? Because otherwise we definitely have no chance. And you see we really need to get here to these, and especially the one I'm looking for is here this 10 nanofarad coupling capacitor. And I've connected this coupling capacitor to here my little leakage meter, right? And well, when I'm testing here this tar capacitor, you see we are dealing here with 10 mega ohm. Okay, that may sound very good. So this capacitor, by the way, is rated with 500 volt DC. So I'm testing here with 500 volt, and what you see is that the needle sticks here on 10 mega ohm. So that is definitely leaking, and especially for our coupling capacitor towards our final audio stage, it is really a problem. So you see that definitely these capacitors have to go, right? So therefore that is what I'm doing. I really go through all here the tar capacitors just to see what's going on, and here is another proof. So we cannot leave it as it is. This tar capacitors or wax capacitors, whatever we have here, has to go, right? Well, just the question why it is so important to have here good capacitors. So we are talking about this coupling capacitor over there. So let me zoom in a little bit. that you are able to see it better. Once again, here we have our audio final tube. So this is a EL41 audio amplifier, right? And we have here a capacitor, a coupling capacitor. So this here, the ABC80, is one portion is our preamplifier, audio preamplifier, right? And what we can see from here, we are getting our supply voltage, right? And it goes right up here to our anode of our amplifier, right? That means at this side of our coupling capacitor we have positive, I don't know, minimum 65 volt. I mean, here is a 200 kilo ohm, whatever, and that means we have here a quite high positive voltage. And here on our grid of our final EL41, we need a minus voltage for holding it working point, right? So we know we need a negative voltage here at our grid 1, okay? If we have here a capacitor which is leaking, then subsequently our positive voltage will be present at grid 1, which means that we do not work at the requested working point, which means uncontrolled DC is flowing through here our final tube. Therefore, it is absolutely essential that coupling capacitors are always very, very healthy. And even it sounds very high when I'm talking about 10 mega ohm, right? It is too less for a most important coupling capacitor like this. So that is another proof that capacitors like this, especially tar and wax capacitors, have to go. So that is the background why it is so essential. Okay, so I have finished more or less the replacing of all the old tar capacitors, and you see down here and there and down there we have our new capacitors in, and we do not see really the electrolytics as they are so small today that you do not really see them. Maybe a little bit down or through down there. That is a ratio capacitor, which is down here, alright, and then our bypass capacitor is here underneath. So you see more or less we have finished it, and of course we have identified here the foil end of our non-polarized capacitors. So you may know that that is important, that you always have your foil end to the low impedance side, right? And anyway, so I was working here at the last capacitor in this area. I mean, okay, so we have here an additional which we need to swap. But anyways, in this area here, this was the last capacitor, and that is, if you like, the power line capacitor, where you use your power network as antenna. So that was very common back in the days, that you really connected your radio over a capacitor to your mains to use that as antenna, right? And okay, so we cannot leave an old tar capacitors for purposes like this in. So normally you need to use a modern XY capacitor, which is made for such purposes, because they are double insulated and so forth and so forth, and that is really here really a risk to your health. So, and while I was doing that, I was of course playing here with the switch, because our net switch is here the last portion, right? So I believe the inner one here is our volume control, and that must be here our tone control. So we have 3 portions here, 1, 2, 3, and the third one is our our switch, our main switch, okay? And that is what we have here. So you may hear it. So that is the switch, right? But I recognized for an unknown reason that suddenly the switch doesn't work any longer. I mean, you know, there must be something went wrong, and it is not switching through to our transformer, right? And I mean, yeah, that is always the pain you are facing if you're touching old devices like this here. I mean, all right, it is 65 years old, and I mean, it is not really a wonder that there might be problems with a switch, but you know, you cannot get any replacement parts for it. So that is really a nightmare if something like this is what you are facing. And maybe I really have to take it completely off, and I have to try to open it to get to the contacts to be able to see why we cannot switch this main switch, power switch, whatever. I don't know. So that is an open connection. Even I switch it on here. Unbelievable. Well, and that you see what I'm talking about. I mean, we have here our main switch, right? So we have here some chokes, and then you see this line here, and let me zoom it in a little bit that you better see it. Right, once again, so then you see this line here, and you see here a 50 PV capacitor, and you see that it is directly connected here to mains, okay? And one side goes over this choke to our transformer. Oops, you can't see it. Goes over the choke to our transformer, okay? And to the other side, we have here a direct connection to, let me bring it down here. So we have here a direct connection here to our antenna connector, okay? And if you do not connect a dipole, right, you can use this little switch, which you can put here to one contact, and then we see that we have finally over our 50 PV capacitor our antenna input connected to the mains. And yeah, you are using actually the mains line for your antenna. Yeah, and you can see it here. So that is the contact which you can put on either side here of our antenna input, and then you're using your power line if you like. And you may imagine that that is really yeah, it is you really need a capacitor which is able to block, you know, your line from your antenna input, because otherwise if you touch, and that is outside your radio, if you touch this contact, you are getting in contact with mains power. So therefore your 50p capacitor needs to be in a very good and safe condition. If it is leaking, it is really dangerous to have it here in the circuit, right? Okay, so however, the issue here with our main switch are really throwing me back because yeah, I can't get it as spare part. I mean, radio of 65 years, no way. And on the other hand, I mean, we really need to have a working main switch, and that means, yeah, I really, it looks like that I really have to take it out, and I have to try to get it apart, to get access here to the contacts, and hopefully I will be able to yeah, finally can fix it. But you know, yeah, that is not nice, because on the other hand I have to disconnect once again all the contacts here on our sound control, and oh, you know. And if you ever have soldered in a radio of this age, you know that all the leads here are banded, and that means you can't get them easily out. So that is always very hard to do. So okay, but there is no other way. We have to look after here our switch, and we need to understand what really has happened here, that we are really so heavily in trouble now. Okay, so we have the switch out, and well, the only thing we can try is to open it by, yeah, trying to get this yeah, this holders, or however it is called, out, to get access here to the switch itself. But anyways, I mean, the problem is we could lose it completely if something is going heavily wrong. But what is on the other hand the alternative? So we have to do something, and let's hope the best. Okay, so having it apart, so you see the switch comes off this way here, and well, when we look here into the mechanic, we see that yeah, we have of course here outside our both contacts, and you see this slider here, and when I move it here, you see that our contacts, right, are sliding here under, and should make contact to each other. So it looks like that basically our mechanic is working, but still there are obviously contact problems, and yeah, let me investigate that a little bit more to understand why there is no continuity if it is switched in. So yeah, let me look a little bit more in depth what's going on here. So I've switched it in, so I mean we can clearly see it. We have the contacts down there, and if I move it over, now we should get contact, right? So when so you hear it beeping, and normally we should of course see continuity, but nothing at all. And on this side we are testing for approximately 100 ohm, so that means there is a big resistor, and here it is completely open according to my meter, right? So that is telling me that we have here obviously a lot of corrosion, and when we go closer, I mean you can see it down here, so really a lot of corrosion, and maybe that is a reason why it is not working. So all the contacts are dirty, and well, again, it is still a risk, but I do not really see what we can do other than trying to take it apart more to get completely access to our contacts underneath, to clean them, and then trying to get it back. But you know, it is really risk, but what other chance do we have? I mean, we finally need to get here our main switch working. So let me try to get it out here, and let's see if then we can clean the contact so that we have at least continuity here. Yeah, we have it out, and I mean, yeah, okay, there is a lot of corrosion, so we can clearly see it. And here this is our little contact plate, and what can we do else and simply try and clean it. Yeah, I'm still a little bit worrying that we will be somewhat in trouble to get it back working, but what can we do? We have to try. I have cleaned the contacts, and well, I mean, you can hear it, but we are missing here some tension, you know. So I'm not sure if I will be able finally to have here enough pressure to hold you know, the contacts in place, to always have continuity when you know, it is switched in. So yeah, I mean, what do you expect? 65 years, and yeah, so that is how it looks like. Okay, but anyways, I try to get it together somehow, and then we will see if our efforts are successful or not. Okay, so we are making progress. We had some difficulties here with our line switch. I mean, it is 65 years old, and so you know, it has broken out here a little bit, so that I needed to put a screw here through to get the mechanic back to move here our switch back and forth. And of course here I have here a little bit Loctite on our washer here on the top. And there we have a little bit deoxidizer on to get here a good contact, and so far it looks pretty promising. And here we cleaned the old grease, and we put some new special on here. And okay, we had where is it? Oops. Yeah, here it is. So we had this metal rivet here to hold here our pot with the switch together, and of course we had to drill it out. So therefore we replace it with screws here, and yeah, we use this to bring it back together. And so yeah, let me put it now together, and let's see how it works out. Okay, so we have fixed here our switch. So you see everything is back, and of course you can hear the click, and that is indicating that our switch is mechanically working. But additional to that, of course, it is important that we have continuity, and yeah, you can trust me, we have. So it is really working just fine, and therefore I can put it back here to our radio, and then let's see how we can go ahead. Okay, so we are making progress. So what you can see here, our pot is back in, and everything is connected so far. And what you can see here as well, I've put down here a mica capacitor, and that is, as I told you, our power line, yeah, antenna, half antenna, whatever you want to call it, but it is involved in the reception function, and you see that it is connected to mains. So that is what I was already talking about. And normally these days you have special capacitors for those functions or circuits called XY capacitors, which are special insulated, that nothing can really happen, so they are very safe, and therefore those capacitors are made for doing jobs like this. But here in our case, I mean, we never get this unit completely safe, as that is one of the old layouts, circuits, where always dependent how you put your socket in your wall plug, you might have, or you will have, power on your chassis. And that is very easy if you watch here our circuit diagram. What you see here is simply that here is mains, right? Here is our main switch, and you see that it directly goes here onto this transformer, but the transformer only reduces the voltage for our lamps and for the tube filaments. But other than that, everything is directly supplied out of our mains. And that is what you definitely can see here, right? So over this switching here, you directly get power here to the unit, and on the other side you see it is here directly connected to ground, right? And ground is chassis, and depending on how you put your main plug into the wall, you may have power directly on the chassis. So that means if you have your main plug, let me call it wrong way around, and you touch the chassis, right, then you get an electrical shock, and that is what you need to know. So you really need to take care if you want to use an old radio like this today. I mean, you know, in the past all the safety regulations was not that advanced, and it was a little bit risky. And today we do it completely different to what we did in the past. And therefore, if you like to use an old radio like this, you need to think about safety, and you need to know what you are doing. Otherwise, it is a little bit tricky, right? So therefore, be careful using old stuff like this. And therefore, I thought, I mean, we cannot make it completely safe. Therefore, we would need to change completely here our transformer. So we would need a complete insulation transformer, so that we have our 230 volt here on the other side as tap. On finally the secondary side, and then we would have mains completely insulated from our circuit, but that is not given here. So therefore we cannot change here our transformer. Then we would really change the entire circuit, so that really makes it complicated. So the only thing you need to know if you want to operate radios like this, you need to know what you're doing. And therefore, we can take the risk and use here a Mica, which is not an XY capacitor, which you should use for it, but a Mica capacitor has a very good voltage resistance. So it is really able to protect, that the voltage can't, how do I call it? I don't know how to call it. It is really, as far we can do it here, it is a safe capacitor, and that is the best you can do if you want to do things like this. In all other ways, use XY capacitors. Just ask Google to tell you what that means and why these special capacitors are today in the market, and then you may understand it a little bit more. Now I've talked so much about these safety capacitors, and just to give you an idea how a capacitor looks like. So you see, this is an X-type capacitor, and that is made for those purposes. So you see here our voltage rating in AC, and you see here all the test markings here on the capacitor, and that is what you should use under normal conditions if you're working on a gear from today. If you do some historic restorations like this, yeah, as I told you, you really need to do much more to get radios like this finally safe. Okay, but we are talking here about restorations, and you see down here we have all new capacitors, and all the old capacitors are, most of them are heavily leaking, and therefore we decided to swap them out. So that is what I've told you before, and you may see down there, so that is our new ratio capacitor for FM demodulation, and then we have here, it is underneath, so we do not see it from here, but underneath here we have our bypass capacitor for our AF tube, cathode bypass capacitor, and yeah, you see here a new capacitor. So that was a little bit tricky because we have all our little wires here from our coils, and yeah, you see over, you cannot see it really, but maybe that way. So when we start this job, we tested here our main filter cap, and we have seen that the main filter cap was leaking, and I told you, yes, we can reform an electrolytic capacitor with a special process, but this radio should work as a daily kitchen radio, and therefore I put completely new Samsung capacitors in here with 105 degree high voltage 450 volt capacitors, so that that is all in a good order, and yeah, therefore we can say that all the critical capacitors are swapped out, and we are here at the point where we can do our testing. Well, and additional, I rearranged my first attempt. I decided to put in here a modern diode, a silicium diode. I think that is more safe, and it is more robust. Well, we know that silicium diode has a different, a lower dynamic resistor, but well, in our circuit we already have 100 ohm resistor in line, so we can take the risk. So that should work without any problems, and I think that is much more robust. I mean, I have I left here the old block simply for nostalgic reasons. That is not what you need to do, but I thought, okay, it works, so I put here this little holder onto it, so that I was able to wire all needed connections in the right way, and yeah, that's fine. The same we have here on our output transformer. I put here new Weimar capacitors. I know that they do not look like originals, but once again, this radio will not become a shelf queen, so it really will go back into daily operations, and therefore it is, from my point of view, a good idea to have high-grade capacitors in the circuit, and Weimar is a very reliable company making modern capacitors. And yeah, there are some other capacitors manufacturers, capacitor manufacturers, who are producing axial capacitors as well. But you know, yeah, if you really like to restore a radio which is yeah, very close to the original one, you should use different ones. Okay, fully agreed. But in this case, radio which really should go back into normal operations, I think that is a good way to do it. But I know there are different opinions. That is mine. You might have a different. No problem. And of course, we start our radio over our protective light bulbs to make sure that nothing goes wrong. And we crank up the voltage at our isolation transformer very, very slowly. And we watch how our radio reacts. And then, yeah, let's see how it finally works. Okay, everything is prepared so far. So let me bring it up here very carefully. So you see here our voltage. You see here the drone. Yeah, drone power is here. So the amps, and here the watts. So yeah, let's see. And I'm watching here my light bulbs, of course, if they will glow or not. So I expect them not to glow. So we will go up very, very slowly. So I already can see here our backlight illumination at the radio. And yeah, so far no light bulb is glowing, so it seems fine so far. Let's go up to 100. Let's wait a second, and yeah, still everything seems to be fine, no problem. Let's go ahead. No glowing light bulb, everything is fine. So our current and our watts are in limits. Very, very nice. Okay. Still everything fine, I believe. Okay. So let's go ahead. 20 watt, still good. And the radio makes noise. Very good. Okay, let's go up to 220 for the first step. Let me reduce here the volume, and now let me reposition the camera. So 35 or 36 is less than we had in our initial test, so that is showing obviously that the power consumption went down, and that is what I really expected, because now we do not have all the leaking capacitors any longer. And I mean, we have tested the main filter cup, and we have seen how heavily it was leaking. And of course, all leaking capacitors will produce additional current, and that is an indication for that the leaking seems to be solved, because otherwise we would see it here on a much higher level. Okay, and the first what we might see as well is that here our background illumination is much better. So that is the old one, and you see how dark it is inside, so that light bulb was not really able to illuminate the background as it should, and you see that is now good. And now let me switch off here some lamps, because the lamps are really interfering here my radio, and you may have heard now that the noise level went down. So that is my light here, and now it sounds much cleaner. Okay, I can't let it on the channel because I do not want to get here copyright issues. But obviously it is receiving. That is a weak station. I'm sorry, I can't really show you that it is receiving quite nice to you know, copyright issues, but yeah, I've tested it, and really it is receiving very nice. Even we do not have here the best reception. Yeah, I do not really have an aerial here up to be able to pick a good signal, but yeah, beside that, it is really receiving very nicely.
Kirche am Erfurt,
yeah,
zwischen der Könebach und
here
Wildeck-Obersuhl hat es einen Unfall auf dem linken Fahrstreifen gegeben, dort Personen im Bereich der Fahrbahn.
So you see, it is really receiving very nicely. But again, music, so I have to stop it. Anyways, so it looks like that it is really working nice. I've tested the tubes on my tube tester, and they all are in tolerance, so maybe the one or the other could be replaced in a while, but they are still all in the good area on my tube tester, so no problems whatsoever. Okay, very promising. Well, and of course we are interested in the sensitivity of our old unit, and therefore you can already hear it. So we have a signal generator here connected to our radio, and yeah, it is my old radio signal generator. And let me reposition the camera that we see a bit more. And here it is. So that is here my old gear for tube radios. So that is back from the time where tube radios were still very popular, and that was back in that time a very modern one. Anyways, today it is more or less nothing special. Well, anyways, the generator is here set to the lowest RF output level, which is 0 dB microvolt, which is similar to what is it? I always forget it. It is similar to minus 107 dBm, but calculated on the 50 ohm system. But anyways, I have here a 75 ohm output, and I have to convert it to 120 ohm, or 240. It is 240, and therefore you know, I'm losing again 6 dB for the radio input, and well, therefore, you know, the generator itself, as I told you, is very old, so it is not really a clean signal, but it is really as low as, I don't know, 107 dBm. And remember, if you have a 75 ohm source and a 50 ohm input, then you know it would be an SWR of 1 to 1.5, which would be acceptable. So I know that all is not 100%, but what we can say, it is simulating a little bit the conditions. So what we're doing here at least is feeding in a very, very low signal into the old radio, and it really does not make any difference if it is minus 100 or minus 107 or minus 115 dBm, whatever. It is a low signal, a low signal we normally would use such an broadcast radio on, and therefore it will give us an indication. Anyways, remember, or we have to consider, so that is more important, that we have here two free running oscillators which are always moving a little bit, and therefore we have to adjust it to get more or less a stable reading. And let me here go back to level, let me increase it. I know it is annoying, so let me go up to 200 millivolt, which will give us a more or less nice reading. Now let me switch it to Synod, and let me adjust it here to the optimum position. As I told you, we are dealing here with two free running oscillators, so that we always have to adjust it here a little bit. And you see, we are, if it is really synchronized, we are at somewhat around 19 dB synod finally. And you know, that means, let me turn it down. So that means with a low level as minus 107 or whatever dBm, and a synod of about 19 dB means that the radio would receive even lower. But once again, that is not the level we would receive a normal broadcast station. So the levels of a normal broadcast stations are always much higher than that. Well, and that all is finally telling us that, you know, it is just fine that we are able to receive such a low level with more or less a good synod. So there is definitely nothing to complain. Maybe in a couple of years, or yeah, if the reception is going lower, then it might be a good idea to swap out you know, the tubes, but for the moment in time it will be fine. So you see, everything is as it should. I do not want to touch it, as you know, it is really a good reception, and therefore don't touch a running system. Okay, let me bring it back into the housing, and then let's go for our final testing. Yeah, and our radio is back to life, and everything is working just fine. I'm sorry that I can't show you how the radio is performing. So the only what we were able to do is to see what the sensitivity does. But as you know, I can't show you due to copyright yeah, issues. So therefore radio is really back and working. So last what I wanted to show you is that the radio is now connected here directly to the net without any isolation transformer, and therefore you know this tool here. And now when I go here to the chassis, I can't really demonstrate it, but okay, I hope you can see it. So I have really here power on the chassis, right? And that is what I have said, that is dangerous. So now if I simply now take here our plug and turn it and then put it back to the radio, okay? And now if I go back here to our chassis, so you see now our chassis is safe, and that is something what we really should have these days. That is, I can't tell it often enough, it is really dangerous. So please take care if you are dealing with radios like this. All the old stuff are doing the same, so be carefully and be warned. Right, that is all I can show you with this radio. I'm really glad that it is back and that it is working just fine. So, thanks for watching, and hope you enjoyed it. That was a lot of stuff you have heard. Maybe you can use the one or the other. And yeah, that is definitely the end of our video. Thanks for watching, and catch you next time. Bye.